start recording. So something out of pocket.
Okay, so today we're going to be looking at if we have to manipulate an equation, what do we do to the K value? So we've already done this when we were talking about enthalpy. So remember we did like the flipping or the multiplying, and then we did stuff to that. That's all that we're doing today. It's just they have different rules for the K instead of the enthalpy. So enthalpy, like if we flipped the reaction, we change the sign, right? If we multiplied by 2, we multiplied it by 2. Okay, for K, it's slightly different. So we'll go over those rules today. So we kind of already talked about this before, but if K is very, very large, what's favored? Do you remember what it was? Products. Yes. So the products are going to be favored if our K is large, greater than 1, right? If it is very large, meaning like over 100, okay, we say that the reaction goes to completion, okay? Because basically, there's almost no more reactants left, and it's almost all products, okay? So we say it goes to completion because all of the reactants become products. Not all of them, but it looks that way, right? So if K is really small, the reactants are favored, okay? So anything less than 1. If it's very small, we just say the reaction does not occur, okay? So this is like if it's times 10 to the negative 10th, okay? That's extremely small. It's basically not happening at all. The reaction's not occurring, okay? If K is 1, the amount of products and reactants will be the same, okay? Because the ratio, right? K is just a ratio. So if we look at this is at equilibrium. Okay, a lot of times on the exam and on your Albert too, they like to give particle diagrams, which that's what this is, where they give you the particles. They give us the equation. It's already balanced. And so what we can do is look at, I counted, yeah. We just count how many we have of each type. Okay, so for our blue single A, how many do we have in the box? Just 1, right? Just this one right here. So we have 1 of our A. How many of the B do we have? 2. There's 1, 2. Okay, and then for AB, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what we can do is we can plug those in to our K value. Okay, they're acting as the pressure of the overall gases. Okay, so for our K P, okay, we would have products over reactants. So the pressure of AB raised to the first value, or to the first power, divided by A, so pressure of A, again raised to the first, pressure of B, again raised to the first. Okay, so just exactly what we did yesterday. Okay, but now we're just going to plug in those values. So my A is 8, or my AB is 8, divided by 1 times 2. So what's my KP? 4. So what's favored? Products favored. Okay. So we would see this reaction occurring. Okay, it's not so small or so little that we barely see it. So we would actually see this reaction occur. But just looking at a particulate diagram and how to go about solving those with K values. Okay, so manipulating K. If we flip the equation like we did before when we were looking at enthalpy, instead of changing the sign, we take the reciprocal of the equilibrium constant. What does reciprocal mean? 1 over. Yeah, 1 over, okay? So for this one, if we flip it, I'm not going to rewrite it, right? But we would flip the products and the reactants, correct? So our K value will then become 1 over 75. could have rewrote the new equation flipped, but just for time's sake, I'm going to continue. Okay? If we multiply a reaction by a coefficient, you take the equilibrium constant to that power to get the new constant. So before we just multiplied, this time we're just going to take it to that power. So if we were to multiply this reaction by 2, we would raise this to the second power. So our K would be 16. Okay, so very simple. You just have to remember the difference when we're dealing with enthalpy. We flip, we change the sign, we multiply, we multiply. For K constant, okay, if we flip, we reciprocate. If we multiply, we take it to that power. Okay, so if you add two reactions together, you multiply the equilibrium constants to those reactions. Before, we just added the enthalpies. Okay, this time we're multiplying to get the new constant. Okay, so for this one, our HI cancels out, so we have H2 plus 2ICl yields I2 plus 2HCl. I combine them. And then my K would be K1 times K2. Okay, so instead of adding, we're going to multiply them. So just slightly different rules. So that would be our new K. Is this it for today? Yeah, so you guys can kind of get caught up on the, because you didn't get very far yesterday. Did you guys on your assignment? Yeah. Okay, so for this one, we have the two reactions. They give us our K value. What would be the expression for the equilibrium constant? This is what equation we're trying to get to. So we need to manipulate these in order to get this. So let's look at N2 first. For this one, I have 1 N2 on the reactant side. So I need to flip the second one, right? Because N2 is only present here. There's only one of them, so I just need to flip this reaction. Okay, O2 will get taken care of by flipping that. For Br2, I need one of them on the reactant side. Currently, I have half on the reactant side, so what do I need to do to this top reaction? Huh? Multiply by 2, yes, times by 2. Okay, and then that would also give us 2 NOBr on the product side when we multiply that one by 2. So we're good in terms of that. So our new K, we're going to have times 2 this reaction, which means we're going to square this. So K1 would be squared times, we flipped this reaction, which means we're going to take the reciprocal. So we'll have 1 over K2. Okay, and if we had actual values, we could calculate it. But that would be the equation that we would plug in the values. Okay, so pretty straightforward. It's very similar to what we did before, but it is different rules compared to what we did with enthalpy.